right, we're told that we've got an equilateral triangle PQR. So from P down to Q, across to R, this is equilateral. So this whole thing across here must also be X. Now don't forget with equilateral triangles, all the angles inside are the same. They all add up to 60, to 180, so they must all be 60. And if each of these is 60, then this is 30. Okay. They've also told us that PS is produced, so PT is also X. So we've also got this line going down here and its length X as well. So the line going across here was also X, but the line going all the way down is X as well. They want to know PQT. So if I draw angle PQT, so that's this whole angle here. So we know that part of it's 60, but we're trying to find the other part. So if I draw the triangle PQT, so this is A. If I draw that triangle PQT, we know this length is X, and we've also been told this length is X. And we know that this top angle is 30. And we know that across here, we know this bit is 60. But we also know that this is isosceles, because this length is the same as this length. So that means that, I'm trying to do this in so many different colours. If I ignore that this 60 exists, that means this whole angle is the same as this whole angle, because in an isosceles triangle, the bottom angles are the same. So I'm going to call these angle A. So I know two lots of angle A plus that 30 up the top equals 180, because it's a triangle. So 2A equals 150, so A equals 75 degrees. And A was angle PQT, 75. Now, that top bit was 60, it was. This top bit to here was 60. So the bottom bit must then be, which is SQT, because this is S here, is 75 degrees, take 60, which is 15 degrees. Okay, so we've done that one. Now let's have a look at B. Show that QS equals half X. Well, we know that triangle PQR is equilateral. So the line QR equals X. We know PS is perpendicular to QR, because they told us that. So therefore the angle, the line PS bisects QR. So it cuts it in half. We learnt that last year in geometry. Also, it just looks like it. Like, it doesn't hurt to go with your gut, by the way. So QS equals SR equals half X. And PS, trying to think, PS, I should use Pythagoras. So this is PSQ. This is X. This is half X. And this is what I'm just going to call it Y. So Y squared plus half X squared equals X squared. So Y squared plus a quarter x squared equals x squared. So y squared equals 3/4 x squared, because 1 whole minus 1/4 equals 3/4. So y equals √3 on 2x, because I'm square rooting the lot, and square root of 4 is 2. Square root of x squared is x. So that was line PS equals, another way to write this exact same thing, half, because the 2 is on the bottom, x √3, because the √3 is on the top. It's a weird way to write it, but it's another way to write it. Okay, and then let's have a look at D. Hence show tan 15 equals to, ooh, okay. So if I draw, they're talking about tan 15. So the only spot we've got 15 is down here in this triangle, yeah? So I'm going to draw that triangle down here. Hopefully using, yep. So this is point T, this is Q, and this is S, and this was 15 degrees. And what do we know about this? We know QS is half x. We know PS, so ST would be PT minus PS. So PT was x. PS we've just discovered is half, that's minus, not equals, half, I'm going to make that √3 on 2x. So we've got x outside of 1 minus √3 on 2. I'm not going to deal with that for now. I'm just going to leave it as it is. So that's ST. That's this length here. And I'm going to try and find tan 15. So tan is opposite over adjacent in this triangle. So we've got tan 15 is length ST, whatever length that is, opposite over adjacent, which is QS, yeah? So for ST, we've got x outside of 1 minus √3 on 2 over adjacent, which was half x. This is a lot going on. But first of all, we have an x top and bottom. So we've got 1 minus √3 on 2 divided by that half on the bottom. I just don't like having a fraction on the bottom, so when I get to things like this, I'd write divides by instead. Now 1 minus √3 on 2, that's the same as if I want to cross multiply 2 over 2 minus √3 over 2 divided by a half, which is 2 minus √3 on 2. Now dividing by a half is the same as keep flip change, timesing by 2 over 1. Now my 2's are going to cancel. And I'm going to end up with 2 minus √3, and it's just over 1. Therefore, tan 15 degrees equals 2 minus √3. Not one I'd memorise, to be honest.